Hello engineers, welcome back. In the previous video, we saw sliding window technique using fixed size and variable sized windows. In this video, we're going to solve a lead code question. Okay, let's get started. So this is the question we're going to solve today. It is a straightforward question. This is maximum average subarray 1. Okay, so let's try to understand the question and let's see how we can derive our solution and then we will code it. Okay, let's get started. So this is a question. You are given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k. So from this statement we can know that we are dealing with a fixed sized window question because it is a contiguous subarray and the length is already given. Find a contiguous subarray whose length is equal to k that has a maximum average value and return this value. Any answer with a calculation error less than 10 to the power negative 5 will be accepted. Okay, so let's take this example and we will see how we can solve this. So let's take this whole thing to our whiteboard. Let's increase the font a bit. Okay, so here's what they're saying. If this is the array 1, 12, minus 5, minus 6, 53, and the window size is 4, we need to get the maximum average. Okay, so if this is the average of the first 4 elements, because window size is 4, 1, 12, minus 5, minus 6, so this is minus 11. 12 minus 11 is 1, 1 plus 1 is 2, 2 by 4 will become 0.5. So this is the average of the first window. Similarly, we can get the average of the second window, the third window. So there are only 3 windows in this question. Okay, so we have already kind of solved it in our theory class when we discussed the treasure hunt example, but let's try to uh, build a similar logic and see how we can solve this. Okay, so what do we need? Let's get our trackers in place. We will need, since this is a window question, we will need window start, we will need window end, and since we are dealing with average, how do we get the average? We get the sum first and then we divide it by the window size. Okay, so this is the sum and then this is simply the window size. Okay, that's how we get the average. So let's keep track of the sum. So we'll need two sums, current sum, which is current total, current window total, and then we need max sum, which is the maximum total. Okay, this is similar to our treasure hunt example. We were doing current gold, max gold. Here we were doing current sum, max sum. Okay, so how do we build the algorithm? Since we know the window size, we will get the first window's sum straight away. So let's initialize our trackers. So we have window start. Let's start it at 0, and then we have window end. We can start it at k. You can also do it the other way. You can do the first window logic first and then start the second window at 1 and this window at window start plus k minus 1. You can also do it this way, but since we have already seen this kind of example, let's do a different example. This is window start at 0, window end at k. Okay, we will trace this, then you will understand in a better way. And let's initialize our other things. We have current sum. One more thing to note here, we are returning the average, which is in a floating point. Okay, so instead of using int, let's use double. Okay, so let's use double for our sums. Current sum equal to 0, double of max sum also 0. So let's get our first window sum. First window, that is very simple. We will simply use a for loop. For int I equal to 0, I will go all the way up to the window size and I++. And what are we doing? We are just getting the sum. Current sum equal to current sum plus array of I. So we didn't name our array. Let's give it a name. Since we are using vectors, let's call this. Oh, we already have a name. Let's use nums. No problem. We can simply use nums of I. So we have the current sum. So let's assume that this current sum is the maximum sum for now. Since we are at the first window, let's assume that we are at the maximum sum. So maximum sum is current sum. Okay. Now we will begin our sliding window. Okay. So how do we slide our window? We check the end pointer, and as long as the end pointer is within the array boundary, we are in play. So we can use a while loop. We can also use a for loop. It's up to you. While window end is less than nums dot size. Since we are using vector, we can use the size function, and we will directly code this in C++ this time. Okay, so how do we move the end pointers? We simply do n plus plus because we are moving the end pointer, but since this is a fixed window question, we will also move the start pointer plus plus. Okay. Now within this window, what do we do? Let's make some space. What do we do here? We are checking the current window sum. So how do we do that? Current window sum, current sum. So as we have discussed in the previous video, how do we get the current sum? When we're dealing with the second window. So if we are here, how do we get this window's sum? We will simply remove the previous element and add a new element, right? That's how we get the sum. So let's do that. Current sum minus nums of window start. We are removing the previous element of the window and we are adding the new element of the window, nums of k. Okay, let's see this with an example. Let's get our array here. 12 1 12 minus 5 minus 6 53. 1 12 minus 5 minus 6 50 and 3. So this is our array, and let's see the indexes 0 1 2 3 4 and 5. So we have initialized window start at 0 and window end at k. Okay, so window start is here, window start, and window end is at k. So what is k? K in this case is 4. So k is 4. So we have window end here. So let's see. So our current sum, after we run our first loop, after we run this loop, what will be the current sum? This will be the first window. 1 plus 12 minus 5 minus 6. So this is 2, right? This is 2. So current sum is 2. If we are here, window start is at 0, window end is at 4. Current sum is 2. Now we we are inside the sliding window logic now. Let's see. Oh, current sum is current sum 2 minus nums of window start. So we are removing the first element. Now no, window start is at 0, right? So nums of window start is here. So we are removing this element and we are adding nums of k. We are adding the new element. Okay. So our window is like this. We are removing the first element of the window. We are adding the last element of the window. Okay. We are removing this one. We are adding this one. Okay. That's how our logic is built. That way we can slide through the window and keep on removing the previous element and adding the next element. Okay. So we get our logic like this. And what else? Here the final step is simple. We just check if the current sum is greater than max sum, right? If current sum is greater than max sum, and we simply update it. Max sum equal to current sum. So far we have seen all this in our previous example also. So we get our max sum. So finally, while we are returning, we need to return the average. Remember, we are not returning sum this time, we are returning the average. So how do we get the average? We will simply say max sum by k. K is our window size, and that's it. Okay, so let's trace this. So we are here. Window start is at 0, current sum is now 2, and now window is moving forward. Window start is as 1, window end is at 5, and current sum is 2. Uh, we have removed 1 and added 50, right? So what will be the new sum? Current sum was originally 2, now it will become 2 minus 1, 1 plus 50. This will become 51, and since this is greater than current sum, max sum is updated to 51. Previously max sum is 2. Okay. Next, we move our window forward, and the window end is at 6 now. And what do we do? Actually, we made one small mistake. Let me trace this again. Sorry about that. So when we are at windows 0 and 4, we already have these values. Current sum. Current sum is already 2 when we have initialized, and max sum is also 2. So here, when windows start is at 0, window end is at 4, then we are updating the current sum here itself. So since we are doing the sliding window while window start is at 0, window start is still at 0, so we are in the while loop already, so we will update it. So what will be the new sum? New sum is 51 here, and max sum will also become 51. And now we can safely update the start and end pointer. Now current sum is 51. Our window is now like this. Window start is at 1 and window end is at 5. Okay, so now this is our window. So what do? We remove the first element, we add the new element. So 51 minus 12, 39. 39 plus 3, 42. Okay, since this is less than maximum, we don't update it. Maximum remains the same. And we move forward. Since now window start is at 2, window end is at 6. Now we are out of the loop because now it has crossed the vector size. We no longer need to check. So we got our maximum sum. Okay. So when we are returning, what are we doing? Maximum sum by k. So this will become 51 by 4, and that will be 12.75. Okay, 51 by 4, 12.75, and that is what we'll return. Okay, so that is our logic. So let's code it on Leet code. Let's see. So what do we need? Let's get our trackers in place. Window start will start at 0, window end will be at k, and we need a couple of sum trackers. Current sum equal to 0, and we need max sum, which is also 0. And let's get our first window out of the way. So we will use a simple for loop, which will go all the way up to window size, and then we are just adding the current sum. You can also use the plus equal to operator, but for easier readability, I am writing it like this. We will simply do nums of I. Nums is our name of the vector. Okay, we are getting vector nums, and k is the window size which is coming in the function input. Okay, so this is our first window sum, and since we will assume that this is the maximum sum, we will equate it to current sum. Now we can slide our window. So what is the logic to slide our window? Window end should remain in play. As long as this is within the vector boundary, we are in play. And how do we increment it? We do window end plus plus, window start plus plus. We are moving both the ends together because we are dealing with fixed size question. Okay, you can also use a for loop, and you can keep track of start and end pointer that way. So what else? So we are moving the window. While moving, we need to recalculate the current sum. Current sum equal to current sum. We are removing the first element of the window, nums of window start, and we are adding the last element of the window, window end. So we got the current sum, and we will simply check if current sum is greater than max sum, we will update it. And that's it. That is our maximum sum logic, and we will simply return max sum divided by k. And since max sum we have declared it as double, we will make sure that the result of this division will be double and not integer, because k is int, right? If we have declared this as int, it would have been a division of int over int, and that would give a rounded value, right? But we need to return double. You can see in the function return type also it is double. Okay, that is also a clue that we need to return double. Okay, so let's run this. Hopefully we have not made any syntax mistake. So our test cases are fine. Let's submit it. And it is accepted. Okay, so that is our logic. So let's quickly discuss the time complexity. So if we had to do this in a brute force method, we would have done it this way. We would have taken the first element, we would have started an inner loop to go to the next three elements and calculated the sum and calculated the average, and then stored them somewhere, and then move on to the next four elements. So that would have become n square operations, which is bad. But since we are using the sliding window technique, we are iterating over the array only once. So we have iterated here for k times, and this window is sliding over it n times. So our time complexity is n operations. Okay, so we have reduced our time complexity using the sliding window technique. Okay, that's how you can utilize this technique. So whenever you are seeing these terms, contiguous subarray, you can start thinking in the lines of a sliding window. And when you see the length is equal to k, it is a fixed size window. When the length is variable, you can use a variable size logic. Okay, so that's how you can use these techniques to solve leet code questions. Okay, so that's it. In the next video we will solve another leet code question, which is having variable length. Okay, so please make sure you subscribe to the channel so that you don't miss out on that. And if you have any questions in this video or any other topic, you can definitely ask me. Thank you so much for watching. Please leave a like if you found this useful, and I will see you in the next one. Thank you. Cheers.